So guys, I'm fixing to start. What I want you to do is I want you to flip over. I think you pretty much all got the ones on the front. If you have any questions, I'll see you individually. But I want to work the ones on the back because there's a few issues with these. Okay? All right, so pH3 plus I2 goes to H3 PO2 minus plus I minus. Okay? So here's the deal. Like I said, whenever I'm trying to do these half reactions, and I'm telling you now, guys, I'm going to get more and more frustrated if you guys do not help me out and do this. I know that it sounds ridiculous, but I'm telling you, I'm forewarning you. When we get to the electro part, there are going to be specific things that these simple little labels are going to make your world so much easier if you will just suck it up and do it and learn it. Okay? So as far as identifying which goes through which, I've got a compound with phosphorus and hydrogen and another compound with phosphorus and hydrogen, and then one with iodine and iodine. I'm going to find the ones that are the easiest to try to determine. That way I'm automatically going to know the other one. So looking at this, which compound do you think is easiest to identify oxidation states? Iodine. So the reactant iodine is 0 because it's neutral and it's in its diatomic form, and I minus is -1. So is that going up or is that going down? That's going down. So is that my reduction or oxidation? It's my reduction. So I know that I2, I actually kind of scrunch this together a little bit. I2 is going to I minus. Now, I know for a fact that the next thing that I'm going to write is true. pH3 is going to H3PO2 minus, and that is oxidation. I don't even have to solve for it. However, I need to show you this in case you ever run into this issue. This is why I'm doing this one with you guys. So let's solve for the oxidation state of pH3. Is it neutral or is it charged? Set it equal to 0. This is kind of weird. The only rule we have here is for hydrogen, right? Hydrogen's rule is it's always a what? Hydrogen. +1 unless it's with a what? A metal. And when it's with a metal, it's what? -1. But it's not with a metal. It's still with a non-metal, right? So what is hydrogen? It's +1. Okay, so I'm going to bring that down. That's +3. So what does phosphorus have to be? -3. So that should make sense. So the reactant phosphorus is -3. Now let's go over there to the other side. What am I going to set this one equal to? -1. Okay, what's the first rule we know to plug in here? Oxygen is -2. So bring your math down. That's what? -4. Hydrogen is our next rule, and what is it? +1. Bring that down. That's +3. And then that oddly shows up. This is why I'm doing this with you. What has to go on that line? 0. As weird as it looks, it's 0. Well, I mean, you can't look at it from that perspective. It's just that in that particular compound, most of the electrons are being exchanged between hydrogen and oxygen. Phosphorus is just hanging out. Yeah, okay. Essentially within the ion itself. Sir? I don't know. I really don't know. No. I don't know why. Well, here's the deal. My question to you still is, we've already assigned it to the oxidation portion. Did phosphorus go through oxidation? Went from -3 to 0. Is that up? So it still went through oxidation. So did I still label it right? Sure did. So it doesn't matter. Okay. It's weird, but the reason I'm showing you this problem is because of that 0. Don't freak out if you get a 0 in the middle of a compound. It's weird, but it's possible. Okay? All right. So let's run through this. Now, I'm going to start, which half is easier to balance? Definitely the bottom half. Why? All you got to do is do a coefficient. And so I'm going to put a coefficient of 2 right here. Now, this is the reduction half, so what side do your electrons go on? The reactant side. And how many am I going to need? 2 electrons. That balances my charge. Okay, that balances my charge. Now let's go to the top one. This is going to be a little bit more challenging. Remember, the first statement is balance everything except the H's and O's. What's the only thing in your top half that's not an H or an O? The P. Are your P's balanced? Yes. Now let's move on. Okay. Next we want to balance the oxygens. How do I balance oxygens? How many waters? To which? 2 to the left. Okay? Now, that just screwed me up. How? Now I got to add more hydrogens. How many? And don't you dare say 4. Two times 2 is 4, plus 3 is 7. Oh yeah, I was thinking. Here's why I said don't you dare say 4. I was looking at it from this 4, not the actual math 4. My apologies. 4 is actually the right answer. My bad. I meant it from, you can't just say, well, there's 4 there, so there's 4 there. I was going to say you have to account for these 3. The math just actually happens to work out that it's 4 on the other side. My fault. That's me. Okay? Now, all my atoms balance. Now I got to balance my electrons. All right, what's the total charge on the reactant side for the oxidation half? 0. All right, what is the charge on the product side of that half? Positive 3. So what do I need to add to make them match? 3 electrons. Nobody on the same page as that? Nicole, you looking at me crazy? Okay. All right. So from this point, do I add them together and I'm done? What must match before you can ever add them together? The electrons. What is the lowest common multiple of 3 and 2? Very good. So I'm going to give this side a 3, and I'm going to give the top a what? A 2. And I'm telling you, number 1, people forget to do that. And number 2, people forget to distribute once they actually have this. Okay? All right, so let's add this together. I've got 6 waters. I've got 2 pH3s. All right, I'm done with the top half. What do I do with my electrons? Cancel them out. I don't need them. And now I've got 3 I2s. We'll stop there and let's kind of catch up, make sure everything looks good. Does my bad. Thank you. It is 4 H2Os. My apologies. 2 times 2 is 4, not 6. Two times 2 is 4, not 6. All right, now let's look at the product side. I've got 2 H3PO2 minuses. I've got 8 hydrogens and 6 I minuses. I know my electrons check because they canceled off. Let's do atoms first. Let's start with the easy one first. Let's do iodine. 6 I's, 6 I's. All right. I've got 2 P's, 2 P's. I've got 4 O's, 4 O's. The hydrogens are going to be the pain in the butt. I've got 4 plus 6 equals 10. What did I do wrong? 4. I'm counting the hydrogens. God, I'm an idiot. Thanks, Madison. This is all your fault. You've messed my math up today. 8 plus 6 is 14. Now let's look at the other side. 2 times 3, that's 6, right, everybody? Yay! All right. And that's 8, and that's 14. So my hydrogens count as well. And then so now I know all my atoms check. Now, one side's really easy for the charge. What is the entire reactant side? It is neutral. Okay. Now let's count the other side. I've got 2 negatives plus 6 negatives is 8 negatives, and then I've got 8 positives. So that checks off as well. Any questions on that one? Okay. All right. Swell, swell, and swell. All right, let's look at one more. NO2 goes to NO3 minus plus NO. All right. So the one thing I need to tell you about this, hint, hint, wink, wink, listen, listen. One compound or one element can go through both oxidation and reduction. One element and one compound can go through both. So is that an example here? Yes. All right, so let's look and see what happens. Now, I am going to need to solve for oxidation numbers here just to kind of see what's going on. All right, so the reactant, this whole thing is 0. That's -2. That's -4. So that makes my nitrogen +4, correct? Okay. Over here, this is -1. That's -2. -6. That makes my nitrogen +5. Right? Okay. I'm going to do it anyways, just to make sure. That is 0, but you are correct. That's -2, -2, +2. So did one compound and one element go through both? Yes. Okay. Now you just got to make sure you set it up correctly. Okay. All right. So the oxidation half. Which one is the oxidation half? NO2 to what? NO3 minus. The reason I know that is because it went up, right? +4 to +5. That's up. That's oxidation. So NO2 going to NO3 minus. Or you could have said, let's do reduction first. Which half went down? NO2 to what? NO. All right, so NO2 going to NO. And what's going to look weird is that both halves have the same reactant. But let's balance it how we know how to do it. Okay? All right. So first of all, are my ends balanced? Let's start with the top half. Are my ends balanced on both halves? Yes. Okay? Are my oxygens balanced? So which side do I need water in the top one? All right, so let's do that. So 1 H2O on the left. All right, what did that just throw off? My hydrogens. So I need how many hydrogens on the right side? 2. Very good. So let's give this 2 hydrogens. And since I am working with the oxidation half, where do the electrons go? The other side. All right, my reactant side is neutral. My product side is a total of what? +1. Well, how do I make it neutral? I add 1 electron. Is that everybody with me so far? Everybody good so far? Okay. All right, let's look at the bottom half. Are my N's neutral? Are my O's not neutral? Are they balanced? They're the same. Very good. So I need 1 water over here, right? Okay. And so now I need 2 H pluses over here. You with me? Pause. My charges aren't balanced, so what do I need where? How many? Very good. So I've got 2 electrons right there. Before you add them up, what must be the same? Your electrons. So let's make our electrons equal. What half am I only adding electrons to? Very good. Okay? I multiply the entire thing by 2. Everybody good so far? Yes, no, maybe? Okay. All right, so this is where it's going to get real weird. I know that this is going to be a lot of writing. I expect you, because you are very proficient people, that you're going to be able to eliminate the garbage I'm fixing to write mentally. But it's just like when you were taught how to divide by each side. You had to draw the line, write it, go to the side, you know what I'm saying? I expect you to mentally be able to do this. All right, so I've got 2 water, so I've got 2H2O plus 2NO2. If you can, go ahead and do it. If you can mentally do it, go ahead. I'm doing it the long way. Stay with me. Just stay with me. Stay with me. You'll see what I mean in just a second. So I've got all the reactants. Do you see what I'm saying by this is the long way? There's a like that kind of looks ridiculous if you think about it. So now let's do the other side. Okay? So I've got 2 NO3 minuses plus 4H pluses plus NO plus H2O. Like I said, that's a lot of writing. Some of this can be chopped down significantly. There's 3 problems with this. Can you have the same compound on both sides? No. Can you have the same compound on the same side written twice? No, that's even dumber. Okay? So we've got to combine like terms. So let's do the easy one first, and let's combine the same one. So these 2 right here, are they the same on the same side? So what do we do with them? Add them together. So I've got 3 NO2s. Now I've got to cancel the stuff that's the same on each side. Okay? So I've got 2 waters and 1 water. Which one wins? The 2. So how many's remaining? 1. So I've got 1 on the left. Why not write H3? Okay? Now, so that takes care of that, takes care of that, takes care of that. Now on the product side, let me go ahead and finish writing the other stuff that I know is there. I definitely know I got 2 NO3 minuses plus NO. I still got to deal with that hydrogen. Okay? So I've got 2 on the left and 4 on the right. So how many remaining on which side? So I've got 2 right there. So let's double check to make sure our ace cancels. The easy one first. Do our electrons cancel off? Yes, okay, so we're good there. All right, let's do atoms. I've got 2 H's, 2 H's. Let's do N's next. I've got 3 N's, 2 plus 1 is 3. Okay, I've got 1 plus 2 is 3 oxygens. 6 oxygens. Plus, okay, so 7 total, and 6 plus 1 is 7, so they all cancel. Check out, so my atoms cancel. What about your charge? Yes. Very good. So this is the final answer. What I have circled is the answer I need you to have. If you can skip the orange and go right into the circle, by all means. Okay? You should never have the same. If it's a different charge, you bring it down. You can't cancel it. No. That's just for you to go back and double check. That has nothing to do with the points. Huh? Interesting. Okay. Sir? Justin? Yes, sir. No. You can. The bottom line is you have to have the stuff at the bottom. If you want to do the orange, what they're going to be looking for is what I have circled. That's what they're looking for. Okay. All right. We've got a few minutes left. Here's what I want you to do. I want you to do below that if you have any room left, or if you need to turn the sheet back over if you have any room. This problem. This is same concept. Do you agree that one thing's going through both? That's why I want you to do this one. Again, you got to remember, this is net ionic. Sometimes things miraculously show up because it's a net ionic. And that's why we have to do the water-hydrogen issue. It's not on yours. You have to write it. Okay. So again, this is one of the same kind of concept, but it's not as difficult because you don't have to have waters and hydrogens in both halves. It's only one half.